Okay, so for those of you that have the MATLAB installed, can you double click on the app? I think you should have a shortcut on your desktop. Do you? So have you opened it? So I have something that looks like this. Do you have something similar? So this is, for the version I gave to you or that I asked you to install, this is what it should look like when you launch it. So what are the segments that we can see on our screen? So what we have here is the windows, MATLAB windows. So that windows contains several other windows also. So if you can see my mouse hovering, so where it's hovering at here is called the command window. It's very crucial to what we'll be doing in this class. Then on the right side, we have what is called the workspace. On the left of the window, we have what is called the current folder or current directory. Then at the top, we have different tabs. We have the home tab. I think by default, you should be at the home tab. Then we have the plots. Okay. Then we have another place called the apps. Okay. So let's focus on the home. At the home, we also have what we call the tool strips. Tool strips. So it is categorized into different commands. We can see what we call the file command groups. We can see the variable command groups. There are several related commands in that section. Then in the code command groups, we have related commands also in that area. Then we have what we call the environment command group also. Related commands are in there. Then we have resources. So that is what it should look like. So I will be using my note as a guide so that we are on track. So that being said, so this is just a pictorial representation of what I've just said. So your MATLAB basically is a calculator. So you can use it to do calculations. So how do we use it to do calculations? So the basic operators in maths is your multiplication, your division, your addition, your subtraction, and your exponentiation. Okay, so how do we use them? Now you see the symbol asterisk is for multiplication. The forward slash is for division. Then the plus sign is for addition. If you want to add, the dash or hyphen sign is your subtraction. Then if you want to do something raised to a power, exponent, your caret sign is your exponentiation. So let's try and do simple calculation using our MATLAB. So to issue a command, you use the command window. I've just shown you the command window. Then there's something called prompt. The prompt is represented by what we have here. So this is your prompt. So if you look at your command window, you should see the prompt. So after the prompt, you can issue a command by typing your expression or your command, whatever you want to call it. So let's multiply 3 by 5. We have said that asterisk is multiplication. So 3 asterisk 5 is the same thing as what? 3 times 5. Can we try that on the command window? So let me try it also. In case you are not sure what we want to do, you can be looking at my screen also. But the note is user-friendly. Likewise, the app. 3 times 5. So how do I get the answer? I will press enter. So the result is displayed on the command window. Yeah. So in addition to that, can you try? Okay, before you try that, let me quickly mention something, even though I'm not there based on my outline. If you look at your workspace, what do you have? Answer equals to 15. That is the answer of the command you just issued. So I have an exercise again for you that says, what do we say you should do? You should add 3 to 7. Can you do that, please? Do you have the answer? So look at the workspace. What do you have there? 10. All right. Okay. So that means if you don't provide a name as your variable name, there is an automatic name that MATLAB gives to it. It gives it answer. But as you begin to work, if you are not providing variable name, that means the answer is going to be overwritten. You don't have a record of what you have done in the past, as in your variables. Because initially you had answer as, was it 15? Now your answer is saying 10. So you have not provided a variable name. MATLAB has been kind enough to give you a variable called answer. But if you have many things you are computing, the only answer is going to be the current answer that you have. So that means it is good enough to have variable name. So let's create a variable name. Let's say m equals to 3 times 5. Can we do that? Let me also try that. For those of you that will be looking at my screen, m equals, is it 3 times 5? So what do we have on the workspace? So you now have a variable called m. So one of the importance of that is, of having a variable name, is that in your subsequent calculations, you can refer to the variable that you have created. Okay? So let me look at my guide again. Now that we have a variable called m stored somewhere, you can do a calculation that says 2 times m. So you are able to refer to the previous variable. Do you want to try that? So you have an answer called 30. It's answer because you didn't give that one a name, but at least you can refer to m that you created. Let me go back to our guide for this class. So we have used assignment operator now when you created the variable m, but let me just say a few things about that. So the assignment operator is your equal sign. So it assigns the expression on the right hand side to the variable on the left hand side. So what do I mean? It's going to do the computation on the right hand side first. Once it has done that, it now assigns the value to the variable which is always on the left hand side. So the variable is on the left hand side, the expression is on the right hand side. So it does the calculation on the right hand side first and assigns it. So with that, you might be able to overwrite a variable. Now we have a variable m, and the answer is 15. It's 15. So I can say m plus 1, and I say that m plus 1 is equal to a variable. So I can still say m is equal to m plus 1. In your typical mathematics, it does not make sense. You cannot say m is equal to m plus 1. But when you are programming, it's different because the computation is done from the right hand side and is assigned to the variable on the left hand side. So that's the difference between your typical mathematics, how you write your equation, and how programming language works. So now, since you have created m before, which is equal to 15, and you are adding 1 to it, it does that and assigns the new answer to whatever variable we call it. So let's do m equals to m plus 1, and let's see if it gives us results. Do you have an answer? So why that does not really make sense in math, that kind of expression, but that is the way programming languages work. What did I write? Oh, so my own answer will be different from yours now because I've made, yeah. So you have 16, right? Okay. So what else do I want to say? Syntax for variable assignment. So when you create a variable, we have said so, you have your variable name on the left hand side, you have equality sign, right? Then you have an expression. So what we have done simply, our expression, which was on the right hand side, was simply, I think we are giving it number. At the time we said, okay, m is equal to 3 times 5. So we could use number or a value, numerical value, as our expression. Okay, then we have used something like m plus 1. So that's a combination of variables and numerical value. Okay, that's the expression which is on the right hand side. So I'm telling you the different forms that your expression can take. Then it could be a function call. You might call a function something like, let's say, sine y. Sine is a function that you are calling. Then as we go, you can have mathematical operators. When we move into something like programming, you can have operators, something like maybe greater than, lesser than, equal to. So those are forms in which your expression can take. So talking about forms of expression, that means we can have manual entry like we have been doing. We entered 2, we entered 3, we entered m. Those are manual entry. Then you can have built-in functions, like sine that I just told you is a built-in function. Then you, as you progress in your understanding of MATLAB, you can create your own function, you can define your own function also. So those are the different forms which your expression can take. So when you are creating a variable, you have a variable name, you have an assignment operator, then you have expression. So expression can be variable, it can be numerical values, you can call a function. What else can we do? We can use mathematical operators, and we can combine all of that or some of that depending on what you are doing. So the workspace, I've talked about workspace sort of as I was working, because all of the variables, if you look at your workspace on the right hand side, all of your variables that you have created are appearing on the workspace. So you know the variables that you have created. Okay, so to reinforce that, you can create another variable called y, and your y is going to be m over 2. Can you do that? Y is equal to m over 2. So our answer is going to be different because I have my m as 1 here by error, and you should have yours as 16. So your y should be 8, y mine is going to be half. So for those of you that are looking at my own, so this is y. This is the command window, this is the prompt. Y equals to, what did I say, m divided by 2. So that's //2. So I have the answer displayed on my command window, and the variable y is now reflecting on the workspace, which is on the right hand side. Any questions so far? Now you discover that everything we've been typing, the result is showing on our command window, right? All of the statements, all of the command that we have issued, we have the results displayed on the command window. But you don't want to display all of the results at different steps because it becomes so loaded that you might not like it. So you might want to suppress some of the solutions. You might not want to display it, even though you want that process to pass through, but you don't want the result displayed so that your window command does not become clumsy. So how you can suppress that is that you can put a semicolon after the command or the statement that you want to suppress the result. So if you put a semicolon, it's not going to display the result on the command window, but the variable or the result is going to be on the workspace. So you are sure that, okay, this result is actually there, even though I'm not seeing it on my command window. So to try that, what do we do? So let's start by saying, okay, already we know, but you can try it. You can say x equals to 5 plus 1 without a semicolon. You have 6, right? Displaying on the window, okay? So now let's put a semicolon. So, let's say x is equal to 6 plus 1 now, and put a semicolon. So let's overwrite it. X is equal to 6 plus 1. Put a semicolon. And press enter. Have you done that? So you are not seeing 6 on your command window, right? But on the workspace, there's something like X. Or for you to be sure, we already have X on that window, right? Do we? We have X on that window. So let's choose a variable that we have not used before. Can you give us a variable that is not on the workspace? No, we'll use A later, so I don't want us to use A now. So let's use B. I don't think I have B in my work today. So let's use B. So let's say B is equal to 5 plus 1. B equals to 5 plus 1, semicolon, please. B equals 5 plus 1, put a semicolon. So I have B on my workspace, but the answer of B is not showing on my. So now let me now say B equals to 2B minus 3. Can I do that? B equals to 2 times B. Remember to put that asterisk. 2 times B minus what? Minus 3. So this time I don't put a semicolon. So press enter. So that means the B we did initially is actually there, and now we are able to refer to it. And now when we want our answer displayed at the final stage, it is showing as 9 on the window command. So what I'm saying is that if you want to suppress the result, you can suppress it. And it might be necessary if you don't want your command window to be littered or clumsy. You might need to do that. So we are just familiarizing ourselves with the interface, things you could do to make your work neater, and then you understand how the process works here. So you can recall a command. Now we have input several commands today. So you can recall command by using the up arrow key. So you have a command that says 3 times 5. M is equal to 3 times 5. So you can recall it by making your command window active. So, we have about 3 sub-windows here. So you ensure that your command window is active. If it's active, typically you should see a blue line, deep blue line, encompassing the window, command window. That tells you that that is what is active. So let's recall that command. M is equal to 3 times 5 by pressing the up arrow key. When you press the up arrow key, it gave you several options. So you scroll up until it gets to what you want, right? So let's say it's not 3 times 5 that you want to write. Let's say it's 3 times B. No, or 2 times B. Or what do we say? B plus 2. Just edit it. So let me say it is 3 times B. So now that I have that, I can use backspace to delete what I don't want. And I can use my arrow key to navigate wherever I want. So do we say 3 times B? So let's say 3 times B. Then I press enter. So I have my answer. So that being said, now initially do we have our answer for M? What's our new answer for M? Depending on what you did. Mine is 27. Okay, depending on what you did. And recollect that we calculated Y using M. We said Y is equal to M over 2. So let's get Y. So if I want to display, I have some variables. So if I want to know what's the value of the variables that I have created, I can just enter the name of that variable and press enter. It's going to give me the value of that variable. So enter Y in your command window. So Y, then I press enter. So what do you have as value of Y? 8. Yeah, mine was half. Okay. Okay. So one thing we have seen that if I type a variable name, if that variable exists, it's going to give me the value. Now I have changed my m. My m is now 27. Why is it that my y that I calculated from m is not changing? Is that not a problem? No, it's not a problem. The way MATLAB works is that when I created y from m, it used the value of m at that time. So we had created a variable y. So now that I've changed my m to another value, if my y should change, then I'm going to issue that command again at the instance of I have created a new value for m, and I think this should apply to y also. So after that m, then I'm going to reissue the command. So if we need to do that, we can still use that arrow key and fetch the formula for y. So I think this is correct. It's still m over 2, right? So just press enter. So you see that the value of y has changed accordingly. So you can use that approach of that hierarchy to make corrections. We'll still get there later. So if you have expressions that you have typed, and maybe there is an error there, so instead of you to type it all over again, if it's a very lengthy expression, it can be prone to error. But if that expression was correct to an extent, you can retrieve what you have and go to the exact point where there is an error and make correction. So you can use that arrow key to fetch previous expression and edit it, as the case may be. So now let's go back to naming our variable. Now, when you want to name your variable, there is a rule. Just like any other programming language that you might have worked with or you will work with, there is a rule for naming variables. So in MATLAB, it has to start with a letter. The name of your variable must start with a letter. Then it only allows letters, numbers, and underscore. So you can't begin to use special characters in naming your variable. It has to be something like letters, numbers, underscore. And the variable name must start with a letter. Then another thing you should bear in mind is that it is case sensitive. Names in MATLAB are case sensitive. Then when you want to name your variable, it is advisable that you use a name that is meaningful, that is intuitive, so that if you are working on a project, you know what each variable stands for, so you are not confused along the line. The name gives you a clue to what that variable is actually doing in the entire process. Then in choosing a name, you must be sure that that name does not already exist in MATLAB. We have talked about built-in functions. Did I mention that there are some functions that are built-in MATLAB? So the name that you are choosing must not be something that exists already in MATLAB. So how do you know that the name that you are choosing does not exist already? You use the command which. So if a name is coming to your mind, so at the command prompt you type which space that name to check if that name is already existing. So if it's already existing, then you can tweak it or change it. So let's see an example on that. So we said something that names in MATLAB is what? Case sensitive. So let's try that. So create a variable called a, small letter a, and give it a value of 8. Then you create another variable, capital letter A, you give it a value of -2. Small a equals 8. Then capital letter A equals to -2. So let's look at our workspace. You see that there is a variable small a, there is a variable capital letter A, different from each other. Okay, so that establishes that names are case sensitive in MATLAB. So what's the next example? So with that, you can use those variables to do other calculations. So if you create another variable called mean AA, capital A, small a, mean AA, and compute it to be equals to A plus A over 2. I mean small a plus capital A over 2. Can you do that? It's going to give you a value. Have you done that? On the board. You want to create a variable. The name of that variable is mean, capital A, small a. And what's the value? The value is small a plus capital A divided by 2. You see it's going to give you the right result. Still establishing that variables are case sensitive. Small letter A variable is different from capital letter A variable. So let me also try that too. So what was your answer? What? 7. 6 minus 2. That's 3. 6 minus, okay, 8 minus 2, 6. 6 over 2, 3. Never mind. Okay, what did you type? So what was the value of your A? Don't worry, we'll get to that. But you see that he gave you an answer. So I know what to do. So I got what I'm supposed to get. I got 3. You don't bother. That validates that my course outline is well structured. So we'll get to why your answer was like that later, maybe in the next class. Alright. So we said we should confirm if this name exists before we choose it, and we said we should use command which. So can you try which exp small letter, and tell me what it gives to you. What do you say? Okay, so that means there is a built-in function called exponent. That's exponent. So it's giving you the directory to exponent in case you need to find out something about it. So that means it already exists. You can't use that. It's not advisable. If you use that, what that means is that it's going to suppress the function. So if you want to call that function, it won't work for you because you have created a variable that has overwritten that. So it's not advisable. So you need to check that, am I not suppressing something I'm not supposed to suppress here? So we have several of it. Can we try which pi? Small letter pi, P-I. What did it tell you? Built-in, right? So, but we did say something that names are case sensitive. So you can, if what you want to do, you want to call it pi, that is what is on your mind, it has to be pi for you. Then what you can do is to leverage on the fact that names are case sensitive. So you can name your own as capital letter, maybe capital letter P, small I, or you can say everything is even capital letters. So if you try which capital letter P and small I, let's try that. So does it exist? So with that, it says not found. So that means you can use it. Then we just try any random variable, which son. So that one will not be found also. You can use that also. So it's advisable that you check if the name exists before you use it. If it exists, there is a way around it. You can use capitalization to differentiate it from what you had previously or what is built in it. So let's move to the next thing. So error message. You can receive error messages. So for example, let's say x equals to 10. Suppress the answer using a semicolon. X equals to 10. x equals 10. Okay, so we know that 5 times x should give us 50 based on our experience in this class. So instead of saying 5 times x, the way MATLAB is going to understand it is that you say 5 asterisk x. If for one reason you forgot to put the asterisk, so type 5x. Let's type 5x. So with 5x, you have 5x, okay? With 5x, you have not spoken the language of MATLAB. It doesn't understand it like that. So it gave you an error message. So you can, now with the error message, it gave you a suggestion. So you can look at the suggestion. If the suggestion is actually what you want, you can accept it. So if you accept it, you just want to get the answer, you press enter. But if you are not interested in that expression, if the suggestion is not for you, you can press escape to get rid of the suggestion. So if you press escape, let's see what happens. So the suggestion disappears and you can now do what you need to do. So now that you have made an error, so we have said something about correcting your error the other time. I think I still have it here. So you can retrace use arrow key to get the function and make some edits if it's something that is manageable. But if it's not something that is manageable, you can type it afresh. So when an error message comes, it comes with suggestion. The suggestion might be useful for you, and if it's not useful, you can press escape to get rid of it. So like I said, MATLAB is quite robust. So people can just lay foundation for you, encourage you like we are doing now. But if you actually want to get the most from MATLAB, it's a do-it-yourself stuff. And it has a function called help that can help you with any idea that you want to pursue in MATLAB. Okay? So you could use help function, and you can also use doc function. But the doc function works when you are connected to the internet. It has to get access to the internet to fetch the documentation for you. But I think with help, even if you are offline, it's going to open a help page for you based on your search word. So there is a function called Randy. Let's say you want to use Randy. Nobody has showed you how to use Randy before, but you know that there is something called Randy that is useful in your current project. So you can type help Randy, or let me just say help space and the function that you are looking for. So in this case, the function is Randy. So can we try that? Let's see, help Randy. Help Randy. Did anything open up? It might take some few minutes for it to come up. Might take some minutes to come up. So what came up is telling you about how Randy works. So if I scroll up, so if you have the time, you can look at it very well. So it tells us that it creates uniformly distributed random integers. So what it's giving us is random integers. So maybe that height is the integer, that rand is the random. Then what are the inputs, the arguments it takes? So you can tell Randy that this is the maximum value that I want, I max. So if the maximum value should give me should not be beyond 10. So if I type something like Randy 10, so whatsoever it's going to give to me is not going to be above 10. That is what that means. Then if it can take two inputs. One is the maximum value that it can have. Then another one is maybe a value. Let's say I want to create a matrix now. If I want to create a 4x4 matrix, so I can say maybe the maximum value in that matrix is 9 or 5. Then if I type something like 4, maybe it's going to create a 4x4 matrix, and all of the elements in that matrix will not be above my I maximum. So let me see the example I have on that and create a 4 by 4 matrix, if I want to create a 4 by 4 matrix, and the number should be between 1 and 20. So what do I do based on the help that came out? So let's look at this line. I hope you can see my mouse. Yeah. So this is what works for it. We'll get to that later on. But let's quickly, just to show you that you can get help on anything, but you just have to settle down and understand what it's saying. So Randy, I have told you that I want to create a 4 by 4 matrix, right? And the range of value should be between 1 and 20. So that means I'm going to supply the maximum value because it can accept I maximum, the maximum interval. So what do I supply first? 20. I'm doing a 4 by 4 matrix. So what will my n be? 4. So I can say Randy. So with that help, I know that if I type Randy, open a bracket and put 20, 4, I should expect a 4 by 4 matrix, and the element in that matrix, none of the elements should be greater than 20. Can you try that? Have you tried it? Okay, now Randy, open bracket, did we say 20, 4? Let me close the bracket. Any output for us? Yeah. So we have a 4 by 4 matrix, and you can see that none of the elements is greater than 20. So you have created a 4 by 4 matrix by yourself by just using help. So that means you can teach yourself anything on MATLAB. So we are just here to guide you, to encourage you, maybe to hold your hands if necessary. That's what we are here to do. So let's say you have access to the internet. Now you don't know the name of that function that works for it, but you have an idea of what you want to do. So you can say, you can use doc as a function. Then you use maybe a phrase that describes what you want to do. So if you use a phrase, you can still get help. So it's going to open documentations that are related to your phrase. But you might not be able to do this now because the access to internet is low. You might want to keep a track of your work sessions so you have a copy of it. So you want to save it as a text file that is editable. Okay, you can use diary to do that. So what diary does is as if is recording all of the process, everywhere you are going, all of the things that is appearing on your window command, so that when you are done, you can view that diary. If you want to edit it, you can edit it. Then, for example, if you are given an assignment or you have an examination or a test, you can use diary to record everything that is there. Then maybe later you now edit the extraneous things and retain what is necessary. And since a text file, you can open it in Word document or anything that works well with text and submit. So I think that's one of the importance of using a diary. But you don't just use diary. Fine, if you enter the command diary, it's going to create that text file for you. But I think it's wise enough to give it a name. Okay, so that you know which of the diary you are looking for. So I have an example. If you issue a command, diary space file name or whatsoever you want to call it, you will see that a text file will be created and you will see it in your current folder. Can you try that? Diary file name. Have you tried that? Okay. So whatsoever you do after creating that diary is going to keep a record of it. So once you are done, you don't want it to record again, or maybe you want to pause it, you just use the command diary off. After offing, maybe later now you want to record more, you say diary on. Immediately you start diary, immediately you create that diary, you start recording. So to be sure of that, you can type any command of your interest. Okay, have you Have you issued a few commands? Okay. Use it. How do you know? Okay, let me try my own. So now one thing is that any name you want to choose for your diary, just like we confirmed the name for variables, you should confirm that name if it does not exist. If there is no variable bearing that name, and if there is no built-in function bearing that name, you should confirm that, right? So once you confirm that, you can use the name. So I already know that there is nothing called file name. So okay, thank you for calling my attention to that. Is it okay now? All right. So let me create mine so that I can understand. Diary, file name, mine does not give any issue. You see the file name here. Okay, so let me say 4 times 3 times 2. Enter. So it records that 2 plus 9. Enter. Okay, there is an error. 3 plus 6. Enter. Okay, so let me see if that diary is recording it. So what do I do? Type file name. My file is called file name, right? My diary is called file name. So let me type file name. So it displays what it is displaying to me. What is inside my what? Is it displaying it to you? Diary of, did you have your diary? Yeah, that's what I said. It's going to record every process. Do you get it? So, but anything, since you have half your diary, if you type anything now, it's not going to record it. So if you do any command after you have half your diary, it won't record it anymore. So if you now type file, if you type the diary again, you won't see all of those processes that you did after you halved your diary. Do you get that? So that's why I said you need to remove every extraneous things using the diary if you are using diary to record your sections. So that's about saving your input and your output. That was what diary did for us to record our work section. So you have created some variables today. If you want to keep your variables, because if you close your workspace now, if you close your MATLAB now, it's going to clear the workspace for you. Now, so all of the variables that you have created, you are going to lose it if you don't save it. So let's say you are interested in using that variable again. You don't want to go through the process of creating them again. So you can save them. So how do we save them? You save them in MAT format. MAT format. So you can create a name. Let's say you are working on a project now. You are working on a project as we are doing. So if on our workspace we type, on our command window rather, if we type save and let's give it a kind of name, let's say work name instead of using file name. I think we have used file name before. So if we say save work name, what happened? Nothing. Let me try my own. It should not be nothing. So we are still working. On your workspace, do you have some variables there displaying? Okay. So at my command window, save space. So I say variable. Let me say var name. Okay. I press enter. So after some time, look at your current folder. Did you see anything different? Okay, so it has created a file. That file is MAT file. So that file contains all of the variables that are on your workspace. So that means if you access that file, you can get any variable that you have created in the past that you want to use. That is what that means. So that's MAT file. So what that does for you is that if you clear your workspace or if you close MATLAB, by the time you load MATLAB again, that file that you have saved is there, and you can load the variables back to the workspace and make use of it or make use of them. So I have told you, when you are creating a name, you should be sure that the name does not exist and is not suppressing anything. So when you want to save your variable, you are at liberty to choose the folder or the directory where you save it. You are at liberty. So it's saving at this directory that you are seeing here. But if I'm not too comfortable with this directory, I can go to environment and click on set path. So when I click on set path, so I see that this is the current directory that is active. So I can choose any folder that is of interest to me. So I can select this, and maybe if I have a folder somewhere, located somewhere, I can choose it, create select folder, then I say okay when I need to say okay, and I close. So that means it is that directory that will be active, but I don't need to create any directory now. I'm comfortable with the directory that I have. But I'm just telling you that you can choose the directory where your work or where your files are saved. You don't have to be stuck to the one that MATLAB has chosen for you, but I'm fine with the one that's chosen for me. So we are seeing two types of saving. You are saving your section, you are saving your variables. Then you can also save your commands for further use, especially when you are working on reasonable project, large project. So you have written some code, you are saying that this code is working to an extent, but you can't finish it at a go, right? So you might want to save the command somewhere, and by the time you are ready to continue, so you fetch that command, you run it again, or if there is anything you need to change in that command, you can change it. So you can save such command in what we call script files, or simply scripts. You can call it script files, or you can call it scripts. So those ones are saved in .m format. The one for variable was .mat, but for this one, for script, is .m. So how do we do that? So one beautiful thing about this script is that once you have the script, it is editable, and you can execute it as many times as you need to execute it. So how do we create that? So let's go to our MATLAB again. So towards the leftmost corner in the tool strip, you have something called new script. So if you click on it, so it opens an editor for me. So you could have typed your script somewhere, and you can paste it here directly. You can copy some of the commands that we have on the command window and bring it here, and you can just create your own script here. So let's just create something randomly. So here, when you are creating scripts, okay, you must suppress the solution, okay? You see, if you look at the bar here, at the extreme, the vertical bar is showing you that there's something not, but if I include a semicolon now, you see that warning will leave. So here you just must suppress it. You see not, the error is still showing there. That means I need to provide a name so that I can be able to use whatsoever I'm creating. So let me give it a kind of name. Let me say Z. So all of the errors are gone. So let me remove the semicolon. You see the error is back. So that means in script you have to suppress all of your statements. But when you are done, you can now execute it. So should we write one more thing? What else should we write? R equals to 8.314 semicolon. So we have legitimately created a script. Okay, so we can now save it. How do we save? Before you run, you should save. But if you don't save before you run, it will prompt you to save it. So to save, just click on this save icon. So you give it a name that you like, scripted notes. So it's going to save in that current folder. So I can save it. Have you saved it? Hold on, please. Hold on, please. Hold on. Can you see your script? Okay, your question. Yeah, the idea here is to be able to save your script for further use or editing. Okay, so you want to see the outcome. Yeah, the outcome will show on your command window if it has to show. But we have not executed it. This is just a command, a series of commands that we are storing somewhere. So we have not executed it. So you might not see anything on the workspace. You might not see anything on the command window. But by the time you execute it, then your results will show on your command window and on your workspace. So now if I run this now, let's say I want to run it. So there is an icon. If you look at the two strips, there is an icon called that looks like play button now. So you click on that and you should see your answer somewhere. So now on the workspace, you can see something like R, and what other variable did we create? You can see Z on your workspace. Then let me see if we have it displayed on so if I want the solution displayed on the command window, I should have included some other commands which I did not include. Maybe it's not of interest to me at this time. I could have printed it, print format. I could have printed those, but that's not necessary for now. But at least you see that it's executable. Then one beautiful thing about scripting is that when you write scripts, sometimes you want to be sure where error is coming, because it's not all the time that you write commands that you get it figured out correctly. It's not all the time you get it figured out correctly. There could be error at some stages. So you might run your script stepwise to know where the error is coming from so that you can correct it. So instead of running it as a whole that I did, I could have segmented it. So this is what I want to do here. So I want to differentiate the first line from the second line. So after the first line, I want to introduce a segment. So what do? I go to this icon called section break. Have you seen section break? At least we have 2 lines of code. So click on section break. What? Okay. So now we have 2 sections. Have you joined us? We are trying to segment now. Do you have at least 2 lines of code in your script? You don't have a script yet? And your script is working fine now. Do you have at least 2 lines of code? So what I said initially was that, have you executed your code? Run it. So is it working? Okay. So you run it once. You run through the code once. The code can be heavier than this, longer than this. Okay. And if part of the codes are correct and part of the code have error, you won't know that you didn't fail everything. You think that everything failed. But for you to know where the where the code failed, you can run it gradually. So creating segments or sections in your script can help you manage how you run your script so that you can identify areas with issues. So we are trying to create sections. Okay, that's where we are. So I said after your first line of script, since I only have 2, so I want to put mine after the first line of my script. So I want to create a section. So I put my cursor after the first line, then I click on section break. Have you done that? Section break. So that means I can run my code section by section. So let me edit what is in here. And let this be 25. Okay. So I can click on the first section. I can make the first section active by clicking on that section. Okay. Then, since that is active, if I click run section, I'm going to have my Z change to maybe 100 or whatsoever it is. Okay, you see that it's only Z that changed. Or maybe your variable for the first line. Larry, have you run the section individually? Okay, so that is telling you that you can decide to run section by section. When you are done with that section, you can run the next section also, or any other section that you want to run. Okay, so you can run it section by section. Then if you don't want to create, maybe you don't want to create sections, then you can click step. So that is going to run your code step by step. So as you are clicking step, it's moving to the next line, it's moving to the next line, and you are able to figure out one or two things. Then let me quickly say something that might be helpful. When you are creating a script or lines of command, it's good to put some useful comments so that anybody that is looking at your script understand what you are trying to do, each step or sizable step of the problem. So you might want to put some comments strategically at strategic places so that people know. So how do we put comments? You use the percentage sign. So if you click on this percentage sign, that's your comment sign. So anything you type after that symbol is going to be seen as a text. It's not going to read it as a code. So when you want to make comments, you use that symbol to ensure that what you are inputting is seen as a comment or as a text instead of a code. So I can say this is the second line. I'm just writing this because that's something that makes sense for what we have here. But based on your project, you can write something meaningful that can guide anyone that is going through your code. So that's how to make comments. When you are done with your code, you can close it. So if you make changes, you save your changes. So let's save it. So now that we have saved it, how do we run the files? This .m files, our script, how do we run it? So you can go to your command and type the name of that file. What's the name of your own file, your own script? Oh, my own script is named scripted notes. So if I call that name on my command window, let's see what happens. So I'm clicking, so I've clicked open. So you know that if you have a script here, you can right click and choose open, then execute it, then it's editable. You see your mouse that is hovering there, that means you can edit it, so your script is there. So managing workspace. So if you have several things that you are working on, for example, let me close my editor. You may close yours too. So if you have, maybe you are doing an exam now, it has variables. Maybe question 1 has variable X and Y. Question 2 has variable X and Y. And question 1 and question 2 are not related. You know, when you create your variables, they are being stored on your workspace. Okay? So if you move to question 2 that is not related to question 1 and the variable name are the same, there might be confusion. Because MATLAB does not know that you have started another project. It is you that know that you have started another project. So you might want to clear your workspace. Once you clear your workspace, those variables are gone. Then you are sure of what the variables you are now creating for this new project. So how do we clear variables in the workspace? So you can type clear at the command window after the prompt. So enter. So it has cleared all of your variables. But luckily enough for you, you know you have saved your variables. You have done saving of variables before. You have saved your variables somewhere. So in case you want to get some of those values, some of those variables later, you already have it saved somewhere. So perhaps before you clear your variable, if they are important to you, you should have saved it somewhere with a name that you will remember. Okay. So let's say you have too much on your command window and you want to get rid of them, you can use CLC to clear your window, command window, CLC. So that clears your command window. To know what variables are available in your workspace, you can use the command who. You know, we just cleared our workspace now of variables. So if you type who, let's see if something comes out of it. What happened? Nothing. So that means you have successfully cleared the variable. Then if you type whos, let's say you have variables there. If you have who, it's going to list all of the variables that are on your workspace. But if you type whos, it's going to bring the variable and some information about the variables. That's whos. But we have nothing there. So these are some of the commands that can help you manage your workspace. Yeah. These are some of the commands that can help you. Instead of clearing all, you can clear a few of the variables. So let's say it's only m that you want to clear. Instead of saying clear, which clears all, you can say clear m. Clear. I'm just using x as an hypothetical example. Whatsoever variable name you want to clear, you say clear that particular variable. So let's load variables. Now you have saved some of your variables, right? So let's load them back to the workspace. You have cleared it, let's load them back. So this works. Once you close your MATLAB and you are back at it, you have your files that contains your variables. So you could load those variables back to the workspace. So what's the variable that we have? We have, mine is called var_name. So let me load it to the workspace. So I use the command load, LOAD. Then the name of that file. What's the name of the file? Get it for your own. My own is var_name. Click enter. So it has put those values back for me. Right? So I can work with those variables. So if I want to know what are the variables that are in my workspace, so I can use who again now. So if you type who now, let's see what it gives to you. It has given you all of the variables that are there. If you type whos, it gives you more information. Some of those information you don't need them now, but that's the difference between who and whos. And now you know that you can get the variables that are there. Okay. So let's save only one. Okay, let me clear my workspace again. Let's clear the workspace. We can clear it, right? CLEAR, and let's try something. So we have cleared everything. We have variable min AA, right? Before, that's one of the variables that we have created. And min AA is part of the variables that are inside var_name. Okay, so let's say it's only min AA that we want to load. We don't need other variables. So what do? We say load. Where are we loading from? From var_name in my own case. So what's my interest? What do I want to load? I want to load min AA. So now I'm being selective, I'm being specific that's what I want to do. So enter. So you have only that. So if you type who, you see that that's the only thing that's going to show up for you. So in the same vein, when we loaded var_name in my own case, I could just have saved any of the items, any of the variables there by saying save from the name of that file that contained it and what exactly I want to save. I could have done that. Just the way I just loaded only min AA. I could just have saved only min AA, sort of. I hope you get what I'm trying to say. So that's the way you manage your workspace so that you can have independence in how the space works for you. So if you want to quit MATLAB, of course, you can type quit, or rather, you can just go to this X icon here, which is and close. Okay. But in case you need the variables, you should have saved the variables. You have seen that. In case you want to refer to what you have done for the entire day, you should have been maybe saving using diary, if diary will work for you. Then if you don't want to repeat your script another time, and you know that you want to revisit those scripts, instead of using maybe the command window, you could have gone to script to type, or when you are done using your command window, you could have copied them and saved them using the script, so that you have a copy of your script. You can have a copy of your variables, then you can have a copy of the work output, everything you have done in the entire time. So diary works for saving your work section. .mat helps you to save your variables. .m helps you to save your command. Any question on what we have done today? Alright, so if you want to close your MATLAB, some of you might type quit, and some of you might use this X icon here. So let me type quit and let me see what happens. Any question before I quit? Okay. Speak louder. Okay. Yeah, of course, we get into that later. So the major thing we did today is to familiarize ourselves with the interface of MATLAB. So we have seen MATLAB as a calculator. So with time, we will look at how to format your digits, then how to do more things with MATLAB. Any other question? Okay. So I'm typing quit. I want to see what happens. Some of you might use the close icon. So MATLAB has been quitted. So by God's grace, we'll see on Friday.